The first airports were established to service airmail carriers. To generate extra revenue, some pilots began bringing along a few passengers who often had to sit on top of the bags of mail. Since many airports were just large, open fields, they were often difficult to distinguish from surrounding farmland. Painting the city name on the hangar roof helped to identify them. Some airports were equipped with a rotating beacon and searchlights, which helped pilots to spot them at night. During the early 1930s, more and more people began traveling by air. Many cities wanted to capitalize on the opportunities for economic growth that airports offered, leading to an airport building boom across America. The following video tells this story.
City squares, buses, churches, plowed fields of black soil, tractors, trucks, and grain in the elevators, rolling hills, hometowns, friends and neighbors, backyards and streets, and the highway over to Junction City. This is America, young, lusty, where necessity has been indeed the mother of invention. The westward push. For 250 years, we spread thin across a continent. Another 50 years and the job was done. The new rawness gave way to dignity and a way of life. People were established. It was time to turn to new things. With great daring and a certain amount of apprehension, a man could buy one of those newfangled buggies, a horseless carriage. This was the year, 1903, that the brothers named Wright, Orville and Wilbur, at Kitty Hawk, North Carolina, put wings on the engine and flew. These were the days people said, "Auto cars? Not practical. Why, we don't have auto car roads." By the 1920s, cars were old hat. But to most people, the Wright brothers' invention was still new. It was at this time they saw their first airplane. The day of the barnstormer had come. You saw them at county fairs. They landed in pastures, took a few of the daring for a ride, and moved on. It wasn't all joy rides. Airplane people were serious. They flew the mail from coast to coast. By 1927, there were 240 airports in the land. City fathers debated the question of where to put the airport. Today, there are 7,000 airports. Every major city has at least one. Almost half of America's airports are publicly owned. They are a public facility like parks and streets, libraries and auditoriums. They are the basis of new industries and the extension of others. They are in growing demand and strive mightily to meet that demand. A third of America lives in small towns and on farms or ranches. These towns have less than 2,500 people and are centers for the surrounding country. Since the first barnstormer landed in the levelest adjacent pasture he could find, the small towns have discussed and planned airports. The biggest question then and now is where should the airport be? How far from town? Or how close to town? Will air visitors walk? Or will there be commercial ground transportation or courtesy cars? The land immediately available was often accepted as solving the question. Today, the town fathers, the civic planners, are more thoughtful. There are examples to study. There is experience to draw from. But most important is the nearly phenomenal growth of airplane usage to be considered. Airplanes aren't an occasional sight anymore. They are common. They are almost old hat. An airport is a terminal, a depot. It should be easily available, as close to town as possible. Airport specifications vary according to altitude and temperature. Local specifications are available from state aeronautics departments. How big is the job of building a community airport? The biggest investment is the land, 15 to 40 acres, level and clear, with good airplane approaches at both ends. Airport expansion must be considered. Longer runways, future parking space, and more hangars. Wise men look back over the past 2 decades and plan for the 20 years to come. Farmers and ranchers are ardent and faithful airplane users. The big ground distances in rural America are reduced 1/3 or 1/4 by flying. This flying is having a strong effect on the economy of raising a crop and bringing it to harvest. Growers have streamlined agriculture, and since the introduction of farm machinery, they have put it on a mass production basis. Since World War II, the airplane to the farmer has been a useful piece of farm machinery. The local airport has become community headquarters for seeding and fertilizing, the application of harvest sprays, the control of weeds, the control of insects and all the principal crops. An airport is no luxury item. It is the hub of thousands of acres of farmland, and to the surrounding community, the rural airport reduces the cost of aerial dusting and spray. The airplanes can be based close to the job, and by this, the savings can be as much as $1 an acre for each acre fertilized, seeded, dusted, or sprayed. One season's work of crop dusting has often paid for an airport. Many farmers and ranchers are airplane owners. They have an airstrip at the home place, but if the combine is down, they are not averse to landing in the stubble to see that the machine is soon going again. Learn to use the airplane like a pickup truck, to go into town for plowshares, axles, or seed. Tomorrow, they'll go over to Eaton to attend the farm auction, and they'll make 12 trips into town before the plowing is done. The government services use community airports in the management of the public domain. At one time, the protection of our 150 national forests depended upon ground crews that often had to hike, trail into the fire. Today, the Forest Service contracts for fixed base airplanes to spot and survey fires. Older planes are usually used for this work since they have short landing field characteristics and are especially suited to the job. Smoke jumper firefighting crews parachute to a position near the fire and put it out before it has a chance to spread. This system of reaching fires while they are small has been in use for well over a decade. It has saved billions of board feet of timber. Smoke jumping has also contributed to the protection of the nation's water supply. The small airport, both municipal and private, plays an important role in the protection of natural resources. Aerial conservation work is done by the U.S. Bureau of Entomology and Plant Quarantine. In the east and in the west, large forest land areas have been sprayed to kill destructive insects. The gypsy moth, the tussock moth, the spruce budworm, the pine butterfly. Since more timber is lost to insects than to fire, this work by airplanes is significant. It has an indirect effect on all Americans. It reaches out to us through our lumber industry, through our nation's wood supply, into paper and furniture and housing and all the products of wood. American industry and business in the West, in the South, in the East, is the #1 user of airplanes and airports. Most municipal airports of the manufacturing centers of New England, the Great Lakes region, and the South are constructed to handle a constant flow of air traffic. Runways are paved. They are long, and there are several of them. They are built for heavy multi-engine aircraft. They are built to handle the executive aircraft of American industry. As industry builds branch factories, as it follows the pattern of decentralization, the smaller cities face an airport problem. There are few large industries today that are not airplane users. Many use both large and small aircraft. The smaller business planes are used by the engineering division, by production, and by the spearheading sales division. As one sales manager said, "We use our airplane because it makes us independent. We make our own schedules. We don't have delays en route. We gain from 2 to 3 days a week. We figure the cost of a trip by regular public transportation and apply it to our airplane fund." The salesmen with big territories to cover are turning to the airplane. They visit the town with an airport like they used to visit the town on the railroad and then the town on the highway. More and more, they will come to the town with an airport. Where is the industry that isn't dependent upon sales? Where is the industry that doesn't want to maintain the position it's reached? Where is its payroll? The flow of America's products from manufacturer to consumer is vital. The consumer is the market. The market found and developed by a salesman. Airports serve in local emergencies. They are part of the plan in case of national emergency. Airports are terminals for freight. Airports are a necessity to a multi-million-dollar dusting and spraying business. They are used by farmers, by ranchers. They are used by families, by sportsmen and vacationers. They are used by the Fish and Wildlife Services, by pipe and power line patrolmen, by local airlines in outlying districts. The first 2 hours after sunup is when most of the planes go out. They may be going on business for a construction corporation, for an oil company, for a diesel engine distributor. It may be a local real estate man, or an orthopedic surgeon, or a mining engineer. They may land at Winnipeg, Atlanta, Mexico City. They may land at Oak Ridge, Fairbanks, Flagstaff, or Anaconda. They may land at your town or mine. For the air is the greatest freeway man will ever know. It doesn't have to be built or maintained. It touches every city and town. So little is needed to use it. An airplane, a smooth strip of ground.
Today, airports are still thriving, and many foreign nationals travel to the United States to take advantage of the flight training opportunities here. Pilots will need to memorize a number of markings and signs found at airports, just as new drivers are required to memorize roadway markings and signs. After watching the video, scroll through the slides that follow to become more familiar with some of them. At the end, you'll see a link to an FAA website where you can download flashcards to help you continue with the memorization process. When flying at night, pilots will also need to become familiar with airport lighting systems. It can be hard to spot an airport at night in a large metropolitan area like Los Angeles. Can you see the airport in this picture? Click on the next slide to find out where it is located. Then watch the video that follows for a good overview of airport lighting systems.
Specialized lighting helps pilots find the airport and runways at night and assist with altitude control during landings. At towered airports, the lighting is usually controlled by the air traffic controllers. At non-towered airports, the lighting can be controlled by timers, photosensors, or by the pilots over the Common Traffic Advisory frequency. Pilot-controlled lighting is activated by keying your microphone for a certain number of clicks within 5 seconds. The number of clicks determines the intensity of the lighting. Most pilot-controlled lighting will turn off after 15 minutes. Information on airport lighting is found on aviation charts and in the Airport Facility Directory. Lighted civilian land airports have a rotating or flashing beacon that flashes alternately white and green. This beacon is usually installed at the top of a metal tower, on a hangar roof, or, at most controlled airports, on the top of the control tower. These beacons flash 24 to 30 times per minute and are aimed at an angle of 1 to 10 degrees above the horizon, so they are best seen when you are at a distance from the airport and may be difficult to see if directly overhead. Rotated beacons are illuminated dusk to dawn, and at controlled airports are often turned on in the daytime whenever the weather is not sufficient for visual navigation. Military airports flash 2 whites between each green, while seaplane airports flash alternating yellow and white. Heliports flash green, yellow, white. Runways with an instrument landing system, or ILS, also have approach lighting systems, or ALSs. There are many different configurations of lights used depending on the environment, but they generally consist of long rows of steady lights with lateral bars, and sometimes include a central set of sequential flashing lights. This light system is designed to help a pilot rapidly transition from flying by their cockpit instruments to flying by outside visual references. The ALS helps the pilot identify the runway environment and orients him for the visual landing. Another light system that can be used is runway end identifier lights, or rails. This system consists of a pair of synchronized flashing lights on each side of the end of the runway and allows airports to provide rapid positive identification of the approach end of that particular runway. To assist pilots on their visual landing approach, especially at night or in poor visibility, VASI and PAPI lights can be installed alongside selected runways. These aids are usually set to show a 3-degree approach path, but at some airports with higher obstructions, the projected angle may be as steep as 5 degrees. VASI, or Visual Approach Slope Indicator lights, are installed alongside the runway, both slightly before and slightly past the desired touchdown point. When above the desired approach path, the pilot sees white lights, and when below it, they see red. By keeping the near lights white and the far lights red, they know they are on glide path. PAPI, or Precision Approach Path Indicator lights, work similar to VASI's, but with 4 lights installed in a single row, with each light angled slightly higher than the previous. Here, the task for the pilot is to keep the outboard lights white and the lights closest to the runway red. 4 white lights would indicate that you are too high. 3 whites and 1 red indicate that you are only slightly high. 2 whites and 2 reds means that you are on the correct angle. As you can now guess, 3 reds and 1 white mean that you are slightly low, and 4 reds mean that you are too low. PAPIs are most commonly installed at larger airports with instrument approaches. Runway edge lighting consists of white lights mounted on short posts about every 90 to 180 feet along the runway edge. A row of end lights can be installed with split lenses, green facing the approach end to mark the beginning of the runway, or, if approached from the opposite end, would identify the end of the runway. Runway lights are classified as high, medium, or low intensity. Some airport runway light intensities are fixed, while at other airports the brightness can be changed by the controllers or pilots. On more sophisticated runways, yellow lights are used instead on the last 2,000 feet of the runway or half the runway length, whichever is less. This marks the caution zone for landings. Runway centerline lighting is flush mounted into the runway itself, with lights about every 50 feet. White lights begin at the approach end, transitioning to alternating red and white lights when at 3,000 feet from the end of the runway, and then becoming all red lights for the last 1,000 feet of the runway. Alternating green and yellow leadoff lights can be installed to direct pilots to the taxiway exits. Taxiway lights are used to outline the edges of taxiways and are blue in color. Some airports may also install taxiway centerline lights, which are green in color. Just like runway centerline lights, these lights are embedded into the ground.
The airport rotating beacon depicted in the next few slides consists of a flash of white light followed by a flash of green light. Military airports have two white flashes followed by a green flash. The rotating beacon is turned on at sundown but may also be turned on during the day when the airport is below VFR minimums. Taxiway edge lights are blue, but some major airports may also mark the taxiway centerline with green lights. The visual approach slope indicator consists of two rows of lights that will appear either red or white, depending upon the angle from which they are viewed on the approach. When the aircraft is below the glide path, the pilot will see two bars of red lights, indicating the approach is too low. When the aircraft is on the proper glide path, the pilot will see a bar of red lights above a bar of white lights. When the aircraft is above the glide path, the pilot will see a bar of white lights above another bar of white lights. The precision approach path indicator consists of a row of 4 lights that will appear white or red depending upon the angle from which they are viewed on the approach. 4 white lights mean the approach is too high. 3 white lights and 1 red light mean the approach is slightly high. 2 white lights and 2 red lights mean the aircraft is on the glide path. 1 white light and 3 red lights mean the approach is slightly low. And 4 red lights mean the approach is too low. There are a number of standardized procedures that pilots will need to learn in order to operate safely in the airport environment. Traffic patterns have been established to eliminate confusion and make taking off and landing safer and more efficient. The standard traffic pattern is a left-hand pattern, meaning aircraft should enter the pattern at a 45-degree angle, then keep the runway on the left while flying parallel to it. Then the aircraft should turn left and follow the base leg until making another left-hand turn to line up the final approach. When departing, the aircraft should fly straight out or make a 45-degree turn to the left. Some airports have a right-hand traffic pattern. This is often done to keep aircraft from flying over a residential or other protected area. The pattern is flown just like a standard traffic pattern, except that the aircraft keeps the runway on the right while flying parallel to it on the downwind leg. All turns are to the right. Some airports have parallel runways with both left and right-hand traffic patterns. When approaching an airport from the opposite side of the traffic pattern, the aircraft should fly over the center of the runway at an altitude of 500 feet above pattern altitude, then make a turn to follow the downwind leg. If the pattern is busy, then the aircraft should fly over the center of the runway at an altitude of 500 feet above the traffic pattern altitude, then continue to fly outbound to a distance of approximately 2 miles. Then the aircraft can descend to pattern altitude and make an inbound 45-degree turn to enter on the downwind leg. Some airports display a segmented circle around a windsock that shows the proper traffic pattern. The shorter portion of the L shape indicates the base leg. In the example shown, the traffic pattern is standard, or left-hand. Pilots can fly over the airport at a safe altitude, 500 feet above pattern altitude, and observe the windsock and its relationship to the segmented circle to determine the best landing runway. In the example shown, the wind is from the northwest, so the best landing runway would be 36 with a left-hand traffic pattern. A tetrahedron is another device that indicates wind direction. The pointed end aligns with the wind direction. An X marked on a runway shows that it is closed. During the flight planning process, pilots should study the sectional charts and identify which runways are available. When there is a right-hand traffic pattern for a runway, it will be marked RP. At Coeur d'Alene, runway 2 has a right-hand traffic pattern. When making a cross-country flight, pilots should also check the airport's website at the destination, which may have important local information that may not be found in FAA publications. The two slides that follow show traffic pattern information for Sedona Airport in Arizona. Review the sample FAA test questions that follow to prepare for the written exam.